Hi guys, this video will help you understand what test data means and also help you understand the different categories of test data as per the IGCSE 921 Computer Science Edexcel syllabus. Let's begin by first understanding what test data is and of course looking at a few typical use cases of it in the industry. Test data is data that is passed into a program or subprogram to see whether it functions the way you need it to function. And usually, test data is of three main facets or three main categories. You have erroneous data that you use to check if the program behaves under uh, erroneous circumstances where the program isn't supposed to function properly. Then you have normal data, which is data that's passed into a program to see if it functions under the normal circumstances. And you also have something called boundary data. And these kinds of data is used to test out whether the conditions are used in the right operators, right? So they are used as means of checking the decision boundaries. But we'll look at that later and we'll look at that in more detail. But in essence, test data is the kind of example test cases or test data inputs that is passed into a program to see if the program functions the way you want it to function. Now, looking at the typical use cases of this in the industry, guys, test data is used in two major types of testing in the quality assurance sector of software engineering, right? You use it for black box testing, which is a kind of testing that is done on subprograms, where the idea is you test the program by passing in some inputs and you see if the respective outputs are the outputs you need. Now, for example, if you've written a function that doubles a number, you check if you pass number 2 if the output is number 4. Imagine you pass number 2 and you get number 5. That's indication that the program doesn't work properly. So as a result, you don't look at what the logic of the program is. You just look at whether the inputs and outputs correspond to each other based on the function that the subprogram is supposed to do. And then you have boundary value analysis, which is a kind of test which identifies the correct boundary values. And there are a few rules associated with boundary value identification as well. But the idea is by choosing the right boundary values, you can figure out whether the right operators are used in the respective conditions. So boundary value analysis helps us determine which variables or which conditions are faulty, basically, right? But having understood that, having understood the use cases, we can now take a look at the different categories of test data in just a bit more depth, starting off with erroneous test data. Erroneous test data is data that is outside the valid range of what is accepted by the program, right? Outside the valid range of what is accepted by the program and thereby should be rejected. And we use erroneous test data, ladies and gentlemen, to test how the program handles errors or unexpected input. Then we have normal data. This is the good, guys. This is the data that falls well within the valid range accepted by the program. Valid range accepted by the program. And we use normal data to see if the program behaves normally, right? We use normal data to test how the program is normally designed to operate. And then last but not least, you have boundary data. Boundary data, ladies and gentlemen, is data that lies at the outer limits of the acceptable input range. So keep in mind, boundary data is acceptable, right? Boundary data is acceptable data. As per your syllabus, boundary data has to be acceptable data, right? But it's on the outer limits of acceptable data. So that's one less than the upper bound and one more than the lower bound. And we'll look at a few examples of this as well. Sometimes there are upper bounds, sometimes there are lower bounds, depending on whether you have, two bounds, right? Sometimes you have conditions where you only have one bound, which in case you only have one boundary data. But otherwise, the boundary data is usually within the acceptable input range, but on the outer limits, right? It's on the limits of what's accepted. And we use boundary data to test whether the decision boundaries or whether our conditions are working properly and whether they use the right operators. For example, have we used a greater than sign when we were supposed to use a greater than equal sign? That's what these boundary data tests are used to validate, right? Whether the decision boundaries or our conditions are using the right operators. So having understood boundary data as data that is on the outer limits of what's accepted and they're used to test out whether the right boundaries are being used, we can now take a look at a quick example where we'll take a look at a quick subprogram, or rather a quick program that is used to perform a score calculation for a school. And we can apply these different erroneous, normal, boundary definitions to find examples of such that apply to this problem, right? So this is a common problem that can come at the exam, right? Either they can ask you to define these kinds of test data, or like I am doing now, they may ask you to find examples of erroneous, normal, and boundary data for a given scenario. So let's see how that's answered. Let's see how this is done at the exam. Let's first try and understand what the program is about. The program starts by receiving some input from the user as an integer. Here, as we can see, the program is supposed to ask the user to enter their score. Maybe it's the English score, maybe it's their math score, but it's some kind of score for whatever exam that they might have sat for. And we say that if the score is not equal to -1, if the score is not equal to -1, then we proceed to ensure that the number is divisible by 3 by checking if the modulus of it divided by 3 is 0. If so, we set the score to score plus 4. Otherwise, we check if the score is greater than 80, and then thereby we set the score to score div 2. Div is the flow division operator where it divides a number by 2, in this case, without any remainders or without any decimal points. Otherwise, it sets the score to score plus 5. So some kind of custom logic that they're applying on the score, after which they check if the score is greater than 90, and then they set a classification variable to high. Otherwise, they check if the score is greater than or equal to 50, and then they set a classification variable to medium, right? Otherwise, they set it to low. And then finally, they output this classification by sending it to display. And they repeat this entire thing until the score entered by the user is -1. So -1 seems to be the exit value of the program, isn't it? And there's a small statement that I've mentioned here where we say that the score is expected to be a number between -1 and 100. So we expect it to always be a number between -1 and 100 inclusive. So the user can enter -1 and 100 as well. Cool. So now that we've understood the overall scope of the program as well as what the expected values are, we are now ready to look at our so-called boundary, erroneous, and normal data. We'll start off by looking at the general expected inputs for our program, right? We'll look at the general inputs. Now, for general inputs, ladies and gentlemen, we know that the score is expected to be between -1 and 100. And these are both inclusive boundaries, right? Because they are inclusive boundaries, I have denoted this green color dot on either boundary, and there is a line joining them. And the fact that these two dots on -1 and 100 are colored in is because these are inclusive boundaries, right? That's what indicates that they're inclusive. But the idea is -1 to 100, where -1 is the exit condition value, which is also a valid value that is accepted by the program just for the program to stop running. But in terms of the actual score, the proper scores are between 100 and 0, right? But keeping that aside, basically -1, 0, 2, 1, 3, 4, 5, 6, all the way until 100, right? All of those numbers are generally accepted values, right? For the purpose of this program, they're all accepted values. So this entire range where the score is greater than or equal to 100 and less than or equal to, greater than or equal to -1, beg your pardon, and less than or equal to 100, right? This entire range is the normal range. There you go. This is the normal range of inputs. That's how you figure out the normal range. It's basically what range of inputs are accepted. Now, when you write this inequality, see what numbers lie on either side of the inequality, right? Ask yourself, are these numbers accepted? Are they in the accepted range? Is -1 and 100 accepted? Yes, correct. They are in the acceptable range. And are they on the edge of the range? Is -1 the smallest acceptable value? And is 100 the largest acceptable value? Yes. Therefore, these two values become our boundary values. So keep in mind, right? -1 and 100 become our boundary values. This is our boundary values. So again, to remind you the definition, boundary values are data that lies on the outer limits of the acceptable input range, which in this case is -1 and 100. They are both within the accepted range and they lie on the boundary. Everything above this range, that's score greater than 100 and a score less than -1. These are examples of erroneous values. That's values that the program shouldn't accept. Or they should, the user can enter them, of course, but the program should be handling them using a graceful if condition or some kind of, mechanism that doesn't make them fall into the same category as valid scores. Now, erroneous values aren't only the values that are outside this range. They could also be values that are not scores of different other data types, for example. So erroneous values could also, for example, be someone entering their name when they are supposed to enter their score, or someone entering a non-integer value like 3.14, because we know that the score is supposed to be an integer, but if they enter a floating point number, that is also erroneous, right? So stuff like that. They could also be outside the range, but they could literally be of a different data type. That too is considered erroneous. So that's how we look at the erroneous, normal, and boundary data for general inputs, where boundary data is -200, -1 and 100, sorry. Normal data is between -1 and 100, inclusive that entire range. And erroneous values are, of course, above 100 or below -1, plus any other values of different other data types like Bob 3.14, and really just any random values that you might enter into the program, or you might expect a user to enter into the program. And the idea is we are testing these values so that way we know that the program performs under any input without crashing. Now, we can also take a look at erroneous, normal, and boundary data for all of our decision boundaries, or our if conditions. Now, let's take a look at how many if conditions we have in our program, guys. We first have an if condition here that checks if the score is not equal to -1. Then we have another if condition that checks if the score modulus 3 is equal to 0. Then we have another if condition that checks if the score is greater than 80. Then we have an if condition that checks if score is greater than 90. The last but not least, we have a score greater than equal to 50 condition. So a total of 5 conditions, isn't it? Now, out of these conditions, you have to first ask yourself, what conditions aren't a binary decision, or what conditions don't lead to a true or false output? Now, let's look at this first condition, score not equal to -1. The relational operator not equals to always results in a true or false, right? Do you understand? Meaning either the score is -1 or it's not -1. I mean, if you think about it, all expressions always result in true or false, but we're supposed to look at what kind of value is accepted here for this expression. Here, the value could be either -1, which accepts the condition, or it could be not -1, which doesn't accept the condition. So if the output itself is binary, then we can't look at boundary data for such equations or for such expressions, right? But we do have normal and erroneous data. The idea here is for this particular condition, the normal data is, of course, anything that's not -1. That's normal. Anything that's not -1 is normal. Anything that's exactly -1 or just -1, that is considered erroneous, right? Because this program only works if the output is not -1. But see, we only have a value that is either not -1 or -1, which in this case results in a bit of a true or false kind of output where you only have one or the other, which in case you don't really have a boundary. However, someone could argue that the boundary here is -1 because that's the value under which the condition either activates or not. But at the exam, you don't get if conditions like this to determine boundaries for. So keep in mind, if your condition has basically these kinds of operators, if you have a greater than, not equal to operator, or if you have an equal to operator, or you have a modulus operator, or you have some kind of div operator. Of course, modulus and div operators followed by an equal sign or a not equal sign, right? These should be followed by an equal sign or not equal sign, or they could be followed by greater than symbols, less than symbols as well. But if mod and div is followed by a not equal to or equal sign, so the culprit here is a not equal to or equal sign, right? If you have a not equal to or equal sign in your expression, you cannot really determine boundaries. So usually, as per the exam and Edexcel's definition of boundaries, guys, if there is an accepted and not accepted value, it's either one or the other, these operators lead to no boundaries. But again, like I said, someone can argue that the boundary here is -1, which I would accept, and of course, Edexcel would also accept. But they wouldn't give you questions pertaining to this for finding boundaries, erroneous and normal data, because in this case, there is no such boundary, right? There is no such boundary. There is either accepted or not accepted, right? Of course, like I said, you can argue that -1 is a boundary, but that's beside the point. The point here is you do have values that are normal. That's anything that's not -1. And you do have values that are erroneous. That's values that are exactly -1. But you don't really have anything in between. So it's very difficult to argue what the boundary is. But don't worry about this for the exam, because in the exam, you often get greater than, less than, equal to operators to determine boundaries instead. The same goes for this score mod 3 equals 0 expression, the second expression, right? The second condition. This is a categorical output, right? The score mod 3 could either be 0 or 1 or 2 or 3, which in case 0 is the accepted value, 0 is accepted, all the others are not accepted. Here also, you really don't have a boundary per se because there's no range, right? So it's either normal or erroneous. For each boundary, the first one and the second if condition, both these if conditions, there's no boundary because they lead to a categorical or some kind of true or false or one or the other output. So here, this second condition also has no boundary, although again, you could argue that the boundary is 0, but that's beside the point, right? You don't get conditions like this for the exam to determine boundaries, although you can look at what the erroneous and normal data are for this particular condition considered. Now we get to a very interesting condition. The third condition is something that we could analyze because here we have a range. What's special about this? For this particular condition, we have a range where the score is to be greater than 80. Now, if you take a look at this particular condition, where the score is greater than 80, guys, any value above 80, right? But not including 80, right? Not including 80. That's why I have drawn a blank circle here. This is the normal inequality notation in mathematics. If the score is above 80 but not inclusive, right? This is considered normal data for this particular boundary, right? For this particular boundary, this is normal. But any value that's less than or equal to 80 for this particular boundary, that's erroneous. Now, what then is the actual boundary? See, boundary data is on the outer limits of what's accepted, right? So what's the first lowest accepted value here? That's 81, because keep in mind we are working with integers here. So the first accepted value is 81, which in turn becomes our boundary. So keep in mind the boundary has to be 81 in this case, because that's the first but lowest accepted value. Perfect. Let's take a look at this score greater than 91. Of course, I don't have to probably explain that to you because it's very similar to the score greater than 81. Let's quickly ask ourselves what the normal, boundary, and erroneous values for this particular condition is. For this particular condition, the normal data has to be, let's ask ourselves what the erroneous data is first of all. Now for this particular condition, the erroneous data has to be the data that is below 90, but also equal to 90, right? So for this particular condition, what is the erroneous values we have? For this particular condition, the erroneous values are less than or equal to 90, right? What's the normal value range? For this particular condition, the normal value range has to be above 90. Then what's our boundary? What's the lowest accepted value? Because it's greater than, the lowest accepted value is 90. So that's our boundary. There you go. It's very similar to what we did with 80. Sorry, my bad. I made a small mistake. Here it's supposed to be 91, right? The boundary is 91 because that's the smallest accepted value. Erroneous is less than or equal to 90. Normal is 90 and above, of course. So there you go, guys. Similar to the score greater than 81. Here, it's again similar, where erroneous is less than or equal to 90. Normal is greater than 90 and boundary is 91 because 91 is the smallest accepted value. Then let's look at score greater than equal to 50. Now for this particular condition, keep in mind, here it's a condition that's a nested condition. What does that mean? The score greater than equal to 50 condition is checked after the first condition is checked. What does that mean? By the time you come here, right, by the time you come to this condition, you have to keep in mind that the scores must be less than or equal to 90, isn't it? So really, you have to be very careful about conditions like this, right? This particular condition isn't really just a score greater than equal to 50 condition. This condition has within itself hidden another condition. What is that? This condition is actually checking if the score is greater than or and equal to 50. And it's also checking if the score is less than or equal to 90. Because this condition is nested after the first condition. So this is the actual true condition hidden inside this nested if condition. So to be very careful. At the exam, you need to be able to unravel the true condition within these nested if conditions. As a result, I can rewrite this as score greater than equal to 50 and less than equal to 90. There you go, guys. Okay, so that's very important. Here, be very mindful. This condition isn't just a plain old greater than equal to 50, right? This condition is greater than equal to 50 as well as less than equal to 90. Now, if you take a look at this one here, we can now apply our, so-called condition 2 inputs, boundary inputs, normal inputs, as well as our erroneous inputs. Let me write down the full condition here. So condition 2 might at a glance look like it's greater than equal to 50, but in reality, it's a full condition that involves both a lower and an upper bound. So here, for condition 2, the boundary is going to be score is greater than equal to 50 as well as less than equal to 90. So what happens in a condition like this, guys? Here, let me mark the two boundaries we have. We have 50 and we have 90. Here, any value including 90 or less than and including 50 or more than, and within this range, of course, right? Within this range, this is acceptable. So any score greater than equal to 50 and less than equal to 90 is normal for this particular condition, right? And then what's our boundary? Our boundary is the lowest and highest in this case because you have two bounds, the upper bound and lower bound. The lowest and highest first accepted value. The lowest and highest first accepted value here is 50 and 90. Therefore, that becomes our boundary. 90 and 50 becomes our boundary because those are the first and last accepted values. And then what about the erroneous? For this particular condition, the erroneous becomes everything above 90, but excluding 90, of course, right? Above 90, excluding 90, and below 50, excluding 50. That's everything above 90 like this, and everything less than 50 like this. Notice how I've not colored the circles because these ranges are exclusive. So keep in mind this is score greater than 90 and score less than 50. And this is erroneous. The red color ranges are erroneous. I think I wrote 90 here, but I meant to say 50, sorry. But there you go. So keep in mind, guys, this is how you look at boundary, erroneous, and general, boundary, erroneous, and normal data for general conditions, general inputs, as well as the actual conditions in your program. But overall, keep in mind, guys, generally, when you look at different test data for a problem, you have to look at the general case, which is often the total possible list of accepted values for a program. And you have to also look at the different decision boundaries. That's the different conditions that you have in your program. The different conditions you have in your program. So for each condition, you can figure out the erroneous, normal, and boundary data. as well as for the overall program. So for the overall program, we figure out the general inputs like this. And for the individual conditions that we have, for the if conditions that we have, we figure out the different examples of input data as well for the different examples of test data. That's boundary, erroneous, and normal. So keep in mind, you can do this for boundaries. You can do this for conditions as well as for the overall program. But that's the gist of it. If you have any questions, do let me know. And best of luck for your exams.